Hi students, now we are going to discuss about chemical bonding. Chemical bonding. What is meaning of chemical bonding? One or more atom can combine with each other to form a new bond known as a chemical bond. The new bond formed between two atoms known as a covalent bond, two ions known as a ionic bond, metal elements or metal known as a metallic bond. In the bond formed between the two elements, the bond contains two electrons. Both electrons donated by any one of the atom means coordinate covalent bond. These four bonds are strongest bond, strong bond. Ionic bond, covalent bond, coordinate covalent bond. Then metallic bonds are strong bond. Another one, weak bond. Intermolecular hydrogen bond with hydrogen, that means called hydrogen bond. Hydrogen bond, van der Waals force, London force is the electrostatic force of attraction known as a weak bond. So, what is meaning of chemical bond? Why the chemical bond formed between the two atoms? All elements have different valence electron configuration. All elements have different valence electron configuration. For example, alkali metal. First A group elements. Lithium, sodium, potassium, rubidium, cesium, francium. Lithium, sodium, potassium, rubidium, cesium and francium. Lithium, sodium, potassium, rubidium, cesium and francium. These elements have valence cell is NS1. NS1. It is a valence cell. For example, lithium. Lithium atom number 3. Electron configuration of lithium is 1s2, 2s1. Sorry, 1s2, 2s1. Sodium 1s2, 2s2, 2p6, 3s1. Sodium outermost cell electron configuration 3s1, potassium 4s1, rubidium 5s1, cesium 6s1, francium 7s1, where n is the principal quantum number, n equal to 2, 2, 3, 4, 5, 6, 7, etc. Where n is the principal quantum number, n equal to 2, 3, 4, 5, 6, 7, etc. In the number of valence cell increases, size of the orbital also increases. So lithium, sodium, potassium, rubidium, cesium, francium has valence cell is 2s, 3s, 4s, 5s, 6s, 7s. It is alkaline earth metal, alkali metal, first A group elements. Next one, alkaline earth metal, second A group elements. Second A, alkaline earth metal. Second A group elements. Beryllium, Be, Magnesium, Calcium, Strontium, Barium, then Radium. Barium, then Radium. General electron configuration of alkaline earth metals are general outer cell electron configuration of alkaline earth metal. The remains called second A group elements are NS2. NS2. Where n equal to 2. Then beryllium, atom number 4, electronic configuration 1s2, 2s2. Magnesium outer cell electron configuration 3s2. Calcium outer cell electron configuration 4s2. Strontium 5s2. Barium 6s2. Radium 7s2. So general electronic configuration of alkaline earth metal, second A group element is NS2, where n is the principal quantum number, n equal to 2, 3, 4, 5, 6, 7, etc. Next one, it is the S-block elements. What is meaning of S-block elements? The outermost electron enter into valence cell of S subcell known as S-block elements. Another one, D-block elements. D-block elements shows the variety of oxidation state with variable valency. Variety of oxidation state with variable valency. That's why number of unpaired electrons are there. That's why it shows the variety of oxidation state with variable valence. 13th group elements. 13th group element is boron, aluminium, gallium, indium, thallium. 14th group element is carbon, silicon, germanium, tin, lead, plumber. 15th group element is nitrogen, phosphorus, arsenic, antimony, bismuth. 16th group element is oxygen, sulfur, selenium, tellurium, polonium. 17th group element is and then fluorine, chlorine, bromine, iodine, astatines. Then 18th group element is helium, neon, argon. Helium, neon, argon, krypton, xenon, radon, oxazons. It is the 18th group elements. 18th group elements 0 valence elements because of completely filled electron configuration. General electron configuration of 13th group Ns2 Np1. So 2 plus 1 totally 3 electrons are there in valence cell. 14th group elements general electron configuration Ns2 Np2 totally 4 electrons are there in valence cell. 15th group elements general electron configuration Ns2 Np3. So 2 plus 3 totally 5 electrons are there in valence cell. 16th group elements general electron configuration Ns2 Np4. So 2 plus 4 equal to 6 valence electrons are there in what? Then 16th group elements oxygen family. 17th group elements general electron configuration Ns2 Np5. 2 plus 5 equal to 7. 7 valence electrons are there in 17th group elements. Next 18th group elements except helium. Helium contains just 2 electrons in valence cell. Remaining neon, argon, krypton, xenon, radon, oxazon, which contain totally 8 electrons are there. That 8 electrons occupy valence cell Ns2 Np6. 2 plus 6 equal to 8 electrons are there. In the inert gas, complete filled electron configuration, there is no unpaired electrons are there. That is why in these elements shows the 0 valency. 0 valency. But the 17th group element contain totally how many electrons? 7 electrons. The element shows the then 7 type of valency, but it exhibit the in the familiar only 1 valency. In the 16th group elements, outermost cell contain 2 unpaired electrons. So exists the 2 valency. 15th group element contain outermost cell contain then totally 3 unpaired electrons. That is why in the nitrogen family exhibit the 3 valency. Another one, 14th group element contain totally how many electrons are there in valence cell? 4 electrons. So valency of carbon family 4. In the 13th group elements of boron, aluminium, gallium, indium, thallium, in the negonium, which contain 3 electrons are there in valence cell of Ns2 Np1. So totally 3 electrons. That's why the boron family contain elements shows the 3 valency. So boron family 3 shows the 3 valency. Carbon family shows the 4 valency. Nitrogen family shows the 3 then plus 2 5 valency or 3 valency. Oxygen family shows the 2 valency. Inert then halogen family shows the 1 valency because of 1 unpaired electrons are there. Inert gas shows the 0 valency because of it is completely filled electron configuration of valence cell. It is a valence cell containing electron known as a valence electrons. Valence electron only responsible for the bond formation. So the chemical bond formed between 2 atom, 2 ion or 2 metal or 2 elements means it is depend upon valence cell contain a number of unpaired electron. Boron family contain totally how many unpaired electron? 3. Carbon family contain totally how many unpaired electron? 4. Nitrogen family contain totally how many unpaired electron? 3 unpaired electron, 1 lone pair of electron. Oxygen family contain totally how many unpaired electron? 2 unpaired electron, 2 lone pair of electron. In the halogen family contain elements which shows the how many unpaired electron? 1 unpaired electron, in then 3 lone pair of electron. Inert gas has no unpaired electron, all electrons are paired up. That's why 4 lone pair of electrons are there in inert gases. It is a valence cell containing electrons known as a valence electron. The valence electron only involve the formation of bond. Valence electron only responsible for the gives the chemical bonding. So all elements have different valence electrons, different valence cell configuration, valence cell electronic configuration. All elements. Then D block elements shows the variety of oxidation state with variable valency. F block elements shows the variety of oxidation state with variable valency depend upon unpaired electrons. In the S block elements consist of 2 groups. One is a first A group alkali metal, another one is a second A group alkaline earth metal. Alkali metal contain only 1 electron in valence cell. Alkaline earth metal contain 2 electron in valence cell. In the P block element contain number of valence electrons depend upon valence cell. So all elements have different valence cell electron configuration. Hence, there are different type of chemical bond formed between the atom. Bond formed between the atom which make the molecules. Nature of the chemical bond shows the different characteristic property of the compounds. So chemical bond can be mainly classified into two types. Chemical bonding or chemical bond mainly classified into two types. One is a strong bond. Another one, weak bond. Strong bond, weak bond. The strong bond further classified into four types. One is ionic bond. Another one, covalent bond. In the next one, coordinate bond. Coordinate bond. The next one, in the metallic bond. It is a strong bond. Chemical bond mainly classified in two types. One is a strong bond, another is a weak bond. Strong bond consists of ionic bond, the bond formed between the two ions. Another is a covalent bond, mutual sharing of electron between the two atoms. Coordinate bond, the bond formed between the two elements. The bond contains totally how many electrons? 2 electrons. Both the electrons donated by any one of the atom. Metallic bond, the bond formed between two metal, known as a metallic bond, maximum exists in alloys. Another is a weak bond. The weak bond consists of two types. One is hydrogen bonding. Another one, van der Waals force. Van der Waals force or van der Waals attraction. In the hydrogen bonding or van der Waals attraction, it is depend upon nature of the bonds. So chemical bond classified into two types. One is a strong bond and one is a weak bond. Strong bond further classified into four types: ionic bond, covalent bond, metallic bond, coordinate covalent bond. Weak bond classified into two types. One is a hydrogen bonding, van der Waals force of attraction. Next one, now we are going to discuss about mainly in the ionic bond. What is the meaning of ionic bond? In the ionic bond formed between the two ions. Why the elements exist ions? It is depend upon stability of the atom. One atom donates electrons to occur the positive charge. Another one atom gain of electron to occur the negative charge. The positive and the negative ions comes close to each other due to electrostatic force of attraction to form of bond known as a ionic bond. In the ionic bond, in chemical bonding, is formed between the two atoms of cation and anions due to electrostatic force of attraction. So electrostatic force of attraction between the positive charge and known as a negative charge to form of bond known as ionic bond. In the ionic bond formed between the two atoms, when two or more valence electron transfer from one atom of valence cell to the another atom of valence cell. One atom of valence cell to the another atom of valence cell. For example, let us consider the two atoms A and B. A atom has one electron excess than the in the inert gases electron configuration. For example, sodium metal. Sodium symbol Na. Sodium metal contains totally how many electrons are there? So what is atomic number of sodium? 11. What is the electron configuration of sodium? 1s2, 2s2, 2p6, 3s1. It is the electron configuration of sodium metal. Another one, chlorine, Cl. Atomic number of chlorine 17. Electron configuration of chlorine 1s2, 2s2, 2p6, 3s2, 3p5. So sodium atomic number 11. Electron configuration 1s2, 2s2, 2p6, 3s1. 2 plus 2, 4, 4 plus 6, 10, 10 plus 1, 11. Chlorine atom number 17. Electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. 2 plus 2 equal to 4. 4 plus 6, 10. 10 plus 2, 12. 12 plus 5, 17. General electron configuration of what? Sodium metal is. It contains 2 electrons because of K cell is a main cell. Main cell contains how many electrons? What is the main cell? K, L, M, N is the main cell. K main cell contains totally how many electrons? 2 electrons. K cell accommodate 2 electrons. L cell accommodate 8 electrons. M cell accommodate 18 electrons. N cell accommodate 32 electrons. 32 electrons. So K cell accommodate 2 electrons. Inga 2 electrons are there. Next, L cell accommodate how many electrons? 8 electrons. 8 electrons. So 2, 8 electrons. Remaining 1 electrons are there. So general electron configuration of a sodium metal according to main cell is 2, 8, 1. 2, 8, 1. The sodium metal has 1 excess electron compared to inert gas electron configuration of neon. What is the atomic number of neon? Neon symbol Ne. Atomic number the 10. Electron configuration of neon is 1s2, 2s2, 2p6. 2 electron in K cell. 2s2, 2p6, totally 8 electron in L cell. So 2, 8. 2, 8. Sodium metal electron configuration 2, 8, 1. Neon elements electron configuration 2, 8. Compare the sodium and neon. It is a sodium electron configuration 2, 8, 1. Neon electron configuration 2, 8. Neon is a completely filled subcell of valence cell. Because of is inert gases, completely filled valence cell, more stable due to extra stability also created on the inert gases. So 2, 8 is a more stable elements. Sodium atom have 1 extra electrons to in the stable electron configuration of neon. That's why sodium atom strong tendency to lose of electron to attain the stable electron configuration of inert gases. Sodium metal Na, loss of 1 electron. 1 electrons are lost to form of Na plus ion. 1 electrons are lost to form of Na plus ions. Because of compared to sodium metal, Na plus is a more stable. Sodium ions is a more stable. Because of it is a stable electron configuration of neon. Neon is a complete subcell of 1s2, 2s2, 2p6. Neon is a more stable. That's why Na plus ion similar electron configuration with neon. That's why Na plus ions are more stable. So according to stability of the metal or metal ion, the sodium atom easily loss of electron. Strong tendency to lose of electron from the valence cell to form of Na plus ion. Na plus ion. That means called positive charged ion. Positive ion. Another one, chlorine atom. K cell accommodate how many electron? 2 electron. L cell accommodate how many electron? 8 electron. In the M cell accommodate how many electron? 7 electrons. So electron configuration of chlorine is 2, 8, 7. 2, 8, 7. Electron configuration of chlorine is 2, 8, 7. In the argon atomic number 18. What is the electron configuration of argon? 1s2, 2s2, 2p6, 3s2, then 3p6. 1s2, 2s2, 2p6, 3s2, 3p6. 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. 12 plus 6, 18. So totally 18 electrons are there. So atomic number of argon is 18. Electron configuration, K cell accommodate 2 electron. L cell accommodate 8 electron. In the M cell accommodate then 8 electron. So electron configuration of argon is 2, 8, 8. 2, 8, 8. But electron configuration of chlorine is 2, 8, 7. 2, 8, 7. That's why the chlorine atom strong tendency to gain of 1 electron to attain the stable electron configuration of argon. To attain the stable electron configuration of argon. So 2, 8, 7 are there in chlorine. 2, 8, 8 are there in argon. So in the chlorine atom, Cl, chlorine atom, gain of 1 electron to form of Cl minus. In the Cl minus ion, similar electron configuration with argon. Cl atom contain totally how many electron? 17 electron because of atom number 7. Cl minus atomic number 17, but extra one electrons are there because of in the chlorine atom strong tendency to accept, strong tendency to gain of one electron to occurs or to attain the stable electron configuration of inert gases, argon, similar to argon. That's why it is a gain of one electron to form a Cl minus ion. Here Na plus ions are there. Here Cl minus ions are there. The Na plus ions of cation and Cl minus ions of anion. So Na plus ions is a cation, Cl minus ion anion. The two ions are comes close together due to electrostatic force of attraction to form of sodium chloride, NaCl salt. Sodium chloride salt. So sodium chloride salt can be obtained from electrostatic force of attraction between the two opposite charged particles. One is a Na plus ion positive charged particles, another one is a Cl minus ion negatively charged particles. Positively charged particle, another one negatively charged particles. So ionic bond is a chemical bonding, is formed between the two atoms by electrostatic force of attraction between the positive as well as the negative ions. The bond formed between the two atoms when two or more electron transfer from valence shell of one atom to valence shell of another atom. Valence shell of one atom to valence shell of another atoms. Here, one atom loss of electron, it will form positive ions. Positive ions, it means called cation. One atom gain of electron, it will form negative ions, it means called anion. The positive and negative ions are comes close together due to electrostatic force of attraction between the opposite charged particles to form of bond known as a ionic bond. So two ions come together to form of bond known as ionic bond. In the ionic bond formed between the two atoms by electrostatic force of attraction, it means the ionic bond otherwise called electrostatic bond. Electrostatic bond. Another one, valence shell contain an electron only participate in chemical bonding, formation of chemical bonding. That's why this bond otherwise called electrovalent bond. So ionic bond, ionic bond in the same concept. Another one, electrovalent bond. Electrovalent bond are in the electrostatic bond. Ionic bond, electrovalent bond, electrostatic bond. The two ions of opposite charged particle can combine together to form a bond known as ionic bond. In the positive and negative charged particles attract together by electrostatic force of attraction known as electrovalent bond. Valence shell contain electron participate in a chemical reaction to form of bond known as a electrovalent bond or electrostatic bond. In these three bond names are same concept: ionic bond, electrostatic bond, electrovalent bonds. Okay, electrovalent. Another one examples are there. Formation of magnesium chloride. Magnesium chloride. The positive and the negative ions are come together by electrostatic force of attraction to attain the stable electron configuration in inert gases and to stabilize the octet electron configuration also. Octet electron configuration. Another one examples are there. Magnesium, Mg, atomic number 12, electron configuration 1s to 2s2, 1s2, 2s2, 2p6, 3s2. 2p6, 1s2, 1s2, 2s2, 2p6, 3s2. In the 2, 8, in the 2, electron configuration of magnesium is 2, 8, 2. 2, 8, 2. Neon electron configuration in the 2, 8 only. 2, 8. Neon electron configuration 2, 8. Magnesium electron configuration 2, 8, 2. The magnesium metal has 2 extra electron compared to neon. That's why magnesium atom is a strong tendency to lose of 2 electron to attain the stable electron configuration of inert gases like neon. Magnesium atom Mg. Loss of 2 electrons. 2 electrons are lost to form of magnesium 2 plus. Magnesium 2 plus ions. Magnesium 2 plus ions similar electron configuration of neon. Because of magnesium contain 12 electrons, but magnesium 2 plus contain 10 electrons. Neon atom also contain 10 electrons. 10 electrons. So magnesium 2 plus similar electron configuration with neon. Another one, Cl, chlorine atom. Chlorine atom number 17. Electron configuration 2, 8, 7. Argon atomic number 18. Electron configuration 2, 8, 8. 2, 8, 8. It is a electron configuration of argon. It is a electron configuration of chlorine atom. In the chlorine atom, atom number 17, argon atom number 18. Argon is a more stable. So due to stability of the chlorine atom, in the accept the one unsaid pair of electron to attain the stable electron configuration of the nearest inert gases like argon. So Cl atom accept the one electron to form of Cl minus ion. Cl minus ions. In the Cl minus ions can combine with the magnesium 2 plus ions. So what is the atomic structure of in the magnesium metal and the Cl minus ion? First in the nucleus. First cell K cell. Then surrounded by second cell L cell. Then M cell. K cell, L cell, M cell. K cell accommodate totally how many electrons? In the 2 electrons. L cell accommodate totally how many electrons? 1, 2, 3, 4, 5, 6, 7, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons. Another one, 1, 2 electrons in magnesium metal. In the 2 electrons are last form of magnesium 2 plus ions. Next, chlorine atom. Chlorine Cl. First cell K cell, L cell, then M cell. K cell accommodate 1, then 2 electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons are there. Next, 1, 2, 3, 4, 5, 6, 7 electrons are there. The chlorine atom contain another one vacant orbitals are there. That's why one electron gained from the magnesium atom. In this, one electrons are transferred to the chlorine atom. In this, another one electrons are transferred to the another chlorine atom to form of magnesium chloride. So magnesium 2 plus ions can combine with 2 Cl minus ion, 2 Cl minus ion to form of magnesium chloride MgCl2. MgCl2. So magnesium 2 plus ion to attain the stable electron configuration of inert gases like neon. Cl minus ion also to attain the stable electron configuration of inert gases near to argon. In these 2 ions are comes close together by electrostatic force of attraction to form of a bond known as a ionic bond. To form of bond known as a ionic bond. In this magnesium chloride contain magnesium 2 plus ion and Cl minus ion to attain the stable octet electron configuration. What is the meaning of octet electron configuration? In a compound contain same elements or in compound contain sundry elements surrounded by totally 8 electrons known as a octet. This magnesium chloride contain both elements are exist the octet electronic configuration. What is mean? Octet electronic configuration. Next one, what are the characteristic property in ionic bond? Characteristic property of ionic bond. Characteristic in the property of ionic bond. Characteristic property of ionic bond. First one, physical state. Physical state. The next one, electrical conductivity. Electrical conductivity. Then melting point. Then solubility. Then density. Hardness. Then brittleness. Then reaction. These points all are characteristic property of ionic compounds. In the ionic compounds was the simplest characteristic properties: physical state, electrical conductivity, melting point, solubility, density, hardness, brittleness, then reaction. Physical state, first one, electrostatic force, electrical conductivity, melting point, solubility, density, hardness, brittleness, reaction. Characteristic property of ionic compounds. In the ionic compound formed between the two atoms of oppositely charged particles by electrostatic force of attraction. The following property also possessed on the ionic compounds, ionic bond or ionic compounds. First one, physical state. Physical state. In the electrostatic force of attraction between the positive as well as the negative charged particles, which shows the in the well-defined geometry, because of in the positive ions and negative ions are arranged in well-defined position. That's why it is shows that well-defined geometry. In the ionic compounds shows the crystalline solid. Ionic compounds all are crystalline solid at room temperature. Crystalline solid at room temperature. Next one, electrical conductivity. What is the meaning of electrical conductivity? In the ionic compounds are crystalline solid at room temperature. In the ions are tightly held with each other. Positive and negative charged particles are tightly held with each other. For example, sodium chloride, NaCl. In the NaCl contain Na plus ion and Cl minus ion. Opposite charged particles are tightly held with each other. Magnesium chloride, MgCl2, which contain magnesium 2 plus ion and 2Cl minus ion, tightly held with each other. So, strong electrostatic force of attraction between the two opposite charged particles known as ionic bond. The ionic bond contain positive and negative charged particles are tightly held with each other, do not freely move through the crystal. That's why in these ionic compounds it is a not good conductor of heat and electricity, not good conductor of heat and electricity in solid state. But in solution state or dissolved state or fused state, for example, sodium chloride finally divided in the form of powder, the powder dissolved in water, then strongly stirred to form of a sodium chloride solution. Sodium chloride solution is a good conductor of heat and electricity because of the sodium chloride is dissolved in water molecule to form of Na plus and Cl minus ion. That Na plus and Cl minus ion easily conduct the heat and electricity. That's why in solid state of ionic compounds do not conduct the electricity. Is a dissolved state or fused state or melting state is easily conduct the electricity because of the ions are freely moved through the crystal. Is the electrical conductivity. Next one, melting point. Strong electrostatic force of attraction between the two opposite charged particles known as ionic bond. In these opposite charged particles of positive as well as negative ions can be separated by high energy required. That's why melting point also increases. Melting point increases. The melting point. Solubility. Polar solvent only soluble in polar substance. Non-polar substance is soluble in non-polar solvent. Ionic compound soluble in ionic solvent. Covalent compound soluble in covalent solvent. Organic substance is soluble in organic solvent. Inorganic substance is soluble in inorganic solvent. Organic substances do not soluble in inorganic solvent. Inorganic substances do not soluble in organic solvent. So, what is the simplest example? Like dissolve like. Like dissolve like. So, polar substance only soluble in polar solvent. Non-polar substance only soluble in non-polar solvent. Organic substance only soluble in organic solvent. Inorganic substance only soluble in inorganic solvent. There is similar to solubility of ionic compound also. Ionic compound is one kind of polar substance. The polar substance of ionic compound only soluble in ionic solvent like water molecules. So do not soluble in the what? Non-aqueous substance or non-polar substance. Only soluble in polar substance like water. Like dissolved like. This is solubility. Next one, density. Ionic compounds is a high density. Ionic compounds are hardest substance due to electrostatic force of attraction between opposite charged particle of positive and negative ions. Ionic compounds is a easy or highly brittle substance. Is easily brittle. Easily brittle substance. Reaction. Ionic compounds undergo the ionic reaction. Is a practically occur in rapid reaction or instantaneous reaction. It is a characteristic property of ionic bond. First one, physical state, electrical conductivity, melting point, solubility, density, hardness, brittleness, reaction. Physical state, electrostatic force of attraction between the two opposite charged particles. opposite charged particles are strong, which shows the in an easily arranged or well-defined arranged and well-defined geometrical form. In the ionic compounds are in the what crystalline solid at room temperature. Next one, electrical conductivity. In the ionic crystal or crystalline solid at room temperature, the ions are not freely through the crystal. That's why ionic compounds do not contain the electrical conductance in solid state, but dissolved state, fused state or melted state, the compounds are easily conducting the electricity. Melting point. Strong electrostatic force of attraction between the opposite charged particles in ionic bond. So high amount of energy required to separate the positive and negative charged particles. That's why melting point also increases in ionic compounds. Next one, solubility. Like dissolve like. Organic substance is soluble in organic solvent. Inorganic substance is soluble in inorganic solvent. Polar substance is soluble in polar solvent. Non-polar substance is soluble in non-polar solvent. Polar substance do not soluble in non-polar solvent. That's why similar to the solubility of ionic compounds are polar substances. Polar substance only soluble in polar solvent like water molecule H2O. Water molecule is do not soluble in non-polar substances like benzene C6H6 and chloroform CHCl3. Non-polar substance. Density. Ionic compounds have high density. Hardness. Ionic compounds are highly hardness due to electrostatic force of attraction between opposite charged particles. Brittleness, it has high brittle. Reaction. Ionic compounds undergo the ionic reaction. It occurs practically rapid and instantaneous process or instantaneous reaction. Okay students, then today topic over. Next topic we will meet the next video. Thank you.